Okay, question of the week, number 3. Foundation and higher first. What do we got to do? Max is saving to buy a computer game that costs £26. £26. Pretty cheap. Maybe it's FIFA 17 before the new one comes out. Anyway, what's he done? He saves 5p, 10p, 50p coins in a jar. There's his jar. And he's been happily plopping the coins in. He's so excited. He's saving and he's saving. Has he got enough yet? Can we buy the game? Right, he saves 5p, 10p and 50p coins in a jar. The ratio of 5p to 10p to 50p coins is 2 to 5 to 1. So 2 to 5 to 1 is 5p's to 10p's to 50p's. That's a chunky pen. There are 120 pens in... not pens. There are 120 coins in the jar. Okay, how much more does he need to save? Right, so we know there are 120 coins in the jar, and we know that if we look in the jar, for every 2 5p's, there are 1, 2, 3, 4, 5 10p's, and there's 1 50p. Okay, so if I take that group of coins there, that's 2 5p's plus 1, 2, 3, 4, 5 10p's plus 1 50p. I make that 2 plus 5 plus 1. That's 8 coins. So if we imagine that little group of coins, that's 8 coins. And we know that the coins stay in that ratio throughout the whole jar. Okay, so we're really thinking we've got 120 coins in total, and we really want to know how many groups of these 8 coins we've got in the jar. If we knew that, we could get going. So how are we going to do that? I reckon we need to do 120. Whoa, chunky pen again. We need to do 120 divided by 8. Okay, we're going to divide by that group of 8 coins. Okay, and I reckon that's going to come to 15. Now, why do I think that? Well, 120 divided by 8. That's an eighth of 120. A half of 120 would be 60. A quarter would be 30, so I think an eighth would be 15. But if we want to try another method, we could say how many 8s into 120? How many 8s in 1? None. How many 8s in 12? 1. Well, I've got 4 left over. Let's carry that 4. How many 8s in 40? 5. 15. Okay, so there are 15 groups, 15 lots of these 8 coins. Let's just check that. 15 times 8, yeah, that makes 120. But we already know that in that group of 8, 2 of them were 5p's. And if we've got 15 groups of those 8, then 15 times 2, I'm going to take my part from the ratio there. 15 times 2 is going to give me 30 5p coins. And if I take my 5 from the ratio, which is all about the 10p's, then I've got 15 times 5 is going to give me 75. There must be 75 10p coins. And 50s. Okay, we'll do 15. I've got 15 lots of those 8 coins, 15 groups of them. 15 times 1, I've got 1 in my ratio, gives me 15 50p coins. Okay, so we know how many of each coin. I reckon we can work out what they're worth. 35p coins. Well, 30, chunky pen, 30 times 5p. Okay, 3 times 5, that's 15. Stick on a 0. That looks like 150p, or £1.50. 150p. £1.50. Okay, what about the 10p's? Well, we had 75. 75 10p coins. That's got to be 75 times 10p. I reckon that's 750. Stick a 0 on the 75. 750p or £7.50. Okay, 50p's. Right, we've got 15 times 50p. Wow. 100 times 15, that'd be 1,500. So we could say this must be half of that, 750. We could just halve the 15, say £7.50. Either way, I reckon we've got 750p again, or £7.50. Mr. Pounds. Right, so how much money's Max got in the jar? Oh, he's getting excited. Has he got enough money in there? Can he buy his game? He's got £1.50. He's got £7.50. He's got £7.50. Well, I reckon we should probably add those together. Okay, well, we could say £7.50 plus £7.50, that's £15. Plus the £1.50, I make that £16.50. He's got £16.50. Right, what was the question? How much more does he need to save? Okay, this is the worst setting out in the world. Try not to make your exam paper look like this. Okay, he's got £16.50 in the jar. The game costs £26. How much more does he need to save? Well, it looks to me like we need to do £26. Take away what he's already got. Take away £16.50. Okay, so if I do 26, take away 16, that's nice and easy, that's £10. But I've got to take away another 50p as well. So I make that £9.50. Okay, if you got £9.50, fantastic. If you're Max, bad luck mate, you got to put some more coins in the jar. Okay, let's have a look at the higher only question. So what have we got to do? Here is an isosceles triangle. An isosceles triangle. That must mean that length and that length are the same. Okay, so isosceles triangle, two side lengths the same, and it's marked on the diagram for me. That's what those lines mean. The hypotenuse is 8 centimeters. Find the area of the triangle. Okay, what am I thinking? Okay, I hope you're thinking area of a triangle. Area equals half base times height. Half times the base times the height. Okay, right. Do we know the base? No. Do we know the height? No. All we know is the hypotenuse. So, again, hopefully you're thinking maybe this is something to do with Pythagoras. We've got a right angle triangle. We know the hypotenuse. So let's have a look. What's our Pythagoras theorem tell us? It tells us that a squared plus b squared is equal to c squared, where c squared is the hypotenuse. Okay, the trouble is normally when we've looked at Pythagoras, we label that a, we label that b. We've known one of the other sides, but here we don't. So the key is that this is an isosceles triangle. And we've already said that those two sides are the same. So the key thing in this question, or at least one of them, is to realise that A is equal to B. The side lengths A and B are the same. Okay, so if they're both the same, we could actually relabel them. We could call them both X, we could call them both Y, we could call them both A. Doesn't matter. They're both the same length. Let's make it A and A. Okay, so these two are the same. Right, so we can now replace our a squared plus b squared in our Pythagoras formula with a squared plus a squared, because a and b are the same length. We've relabeled them a and a. So we're saying a squared plus a squared has to give us c squared. And we know what c squared is. We know what c is. C is 8. So let's try and simplify what we've got. A squared plus a squared. What am I going to do there? A squared plus a squared. Is that a to the power of 4? No. Is that 2a? No. We've got 2 lots of a squared. That just gives me 2a squared. I've got 1a squared, I've got another a squared, that's 2a squared. Okay, so a squared plus a squared, we've got 2a squared. Equals c squared. Well, we know c is 8. So I can say 2a squared equals 8 squared. And I know that 8 squared is 64. So we've got 2a squared equals 64. Right, what do I want to do here? Okay, I've got 2a squared equals 64. I reckon we need to divide both sides by 2. Okay, divide both sides by 2. That's going to give me a squared equals 32. Right, so a squared equals 32. What do I want to do now? I want to square root both sides. That will tell me a, and it will tell me, oh, that's not nice, 32. If it was 36, root 36, that would give me 6. It's not a nice number. So I'm going to leave it as root 32. And that's okay. I'm not going to grab my calculator. It's a non-calculator paper. Okay, we're going to leave a as root 32, whatever that is. Okay, so we now know the side length a. Let's get rid of all this. We've calculated that a is root 32. And this side, a as well, is the same length as the square root of 32. So now we know what we need to know. Right, let's go back to our area formula. We're going to say that our area equals half times the base. What's the base? The base is square root of 32, root 32. And we're going to do half times the base times the height. What's the height? Oh, it's root 32. Okay, now we can simplify. Right, area equals half times root 32 times root 32. Okay, now if we've learned our rules, or if we think this through, I reckon that's going to be the same as 32. If you're struggling to see that, it's just down here for a minute. Try it with some numbers that you'll recognise, some easier ones. What if we've got root 4 times root 4? Is that the same as 4? I think it is, because root 4 is 2 times root 4 is 2. That does give me 4. Okay, right, you should just take a minute to verify for yourself that this is going to work for root 6 times root 6 would give me 6, and root 32 times root 32 is definitely going to give me root 32 times root 32 is definitely going to give me 32. Okay, right, when you're absolutely happy with that, let's go back. We've got a equals half times 32. Well, I can always replace that times with an of. This is like half of 32. This is 16. 0.5 times 32, 16. Half of 32, 16. Half times 32, 16. So we're done. What's our area? Area equals 16 square centimetres. Yay! Now, if only Max had have done these questions rather than saving up for that computer game and spending all of his time playing it, he'd have got much better GCSE grades. Bad luck, Max. See you next time.